So let's start out with a review. First go down and come up with your own answers, and then discuss them in your group. Choose the top 3 answers. And here are the 2 questions. Why does sequential logic need a clock signal, and combinational logic doesn't? So remember, that was the big difference we had between them. And what are the differences between SRAM and DRAM, and why should we care about them? So, why does sequential logic need a clock signal and combinational logic doesn't? Well, remember the clock signal is the thing that comes in here and tells the circuit when to update. So when the clock comes in, we store the values, that is the state, and the combinational logic just calculates them. So we're going to use this for 2 different things. The combinational logic is going to compute the next value, and the sequential part is going to store that value. So remember, we store them in a state element, like a flip-flop that we see here, and the flip-flop has a clock that goes into it. When the clock comes into the flip-flop, we take whatever's on the input here, and we transfer it over to the output. So at this point, what was on the input is now stored inside the flip-flop, and it's saved there, so it can be output even if the inputs change. The combinational logic, however, just changes based on its inputs. So if we've got combinational logic here and we have an input, the output's going to change immediately. So we need to have this state here in order to save it, so that if we go through and we do this feedback loop, it won't just loop around all the time. So the combinational logic's job is to take an input and take the current state and figure out what the next state is, and the state element, or the flip-flop here, its job is to store the previous state until the clock comes around, in which case we'll update to the next state. Now, what are the differences between SRAM and DRAM? Why do they matter? Well, SRAM uses powered transistors to store value. Remember, we have a feedback loop. So here's the feedback loop that we have in SRAM, and 1 transistor to get the output. This is large, takes a lot of transistors to do this, so it takes up a lot of area and is expensive. But since these are active powered transistors, they can drive out more current, so it can be faster. It can change the voltage on this wire faster, which means you can read it more quickly. DRAM, however, was the opposite way. It uses capacitors, so these are passive, they're not powered. So there's just a little bit of charge in the capacitor, you turn on this transistor and some of that charge comes out on the wire and slowly changes the voltage on the wire. Because you're limited how much charge you have here, it's going to change the wire very slowly, which means they're slow. However, they're slow, but they're very small, which means it's cheap. So DRAM is small, slow, and cheap. SRAM is large, fast, and expensive.